what's up, Gomez gang? Today we're going to talk about something that's extremely important that I'm not sure if you guys are getting the grasp of as much as I would like you to. So this video might be a little bit long, but it's going to help you so much in the long run. Today we're talking about compound probability with different likelihoods. These are the situations where it's like, hey, someone's shooting a penalty kick or someone's shooting a free throw, and there's a 50%, like an 80% chance that they make it, 20% chance that they miss, etc., where it's not like a heads or tails where it's an equal likelihood of 50%. So we're talking about compound probability with different likelihoods. This is what this question is about. I'm going to show you how to visually represent it as well as solve it mathematically. So we're going to read it first. Roger plays for his school basketball team. He makes 80% of the shots that he throws. Roger is given the opportunity to throw 2 free throws in a row. If he makes the first one, he is able to shoot a second time, but if he misses his first shot, he forfeits his second shot. In other words, he will not be able to shoot a second time. So the first question is asking you, what are the possible outcomes for the situation? Great. So this is not going to work with a tree diagram. That is not the situation that we're looking for right now. Instead, we're going to look at an opportunity or a way to represent it as such. So we have shot number 1, and we have shot number 2. And that's just a really quick T-chart just to represent this. So one possible outcome is making the first one, making the second one, right? And that's actually pretty likely because he makes it 80% of the time. Now, another possibility is that he makes the first one but misses the second one. That can also happen. Another possibility is him missing the first one. Now, this is where some people make a really common mistake. There shouldn't be a checkbox here, nor should there be a second row of XX. X check and XX do not exist because, again, if he misses his first shot, he does not have an opportunity to shoot a second shot. So it's almost as if this doesn't exist because in reality it doesn't. These are the only 3 possibilities that can happen, which is make, miss, and just miss. Those are the only 3. That is the possible outcomes. That is the sample space. Now, the next question asks, what is the theoretical probability of each possible outcome? And you got to use a model to solve. There's a lot of different ways that we can go about this. First, I want you guys to view this as a sequence of events. In other words, this second shot cannot happen unless the first one happens first, of course. So understanding this check mark as making the second one after I've made the first one is extremely important. Just like this X and this X are completely different. This X represents missing the second shot, whereas this X represents missing the first shot. So to represent this, I'm going to use a 10 by 10 grid. Great, so here I have a 10 by 10 grid. So there are 100 total squares, each square representing 1%. To represent this problem of 80% make and 20% miss, I'm going to use light green to represent making my first shot and just a simple red to represent missing my first shot. So as we know, there's an 80% chance of making my first one. So if I know that there's 10 this way and this would be 8, I'm just simply going to color or shade in 80 of my boxes. Now, it does not have to be perfect. It's just a quick little model to show you. So hopefully this is clear enough to see that there are 80 green boxes or light green boxes, and that represents me making my first shot. Again, the red will represent me missing my first shot. So I'm going to represent this as just 20 or 2 columns of red. Great, so we have 80, 20, this is making my first, this is missing my first. Now, I need to represent my second outcome, my second sequence of events. So the first one was making the first shot, now I gotta represent my second shot. Now my second shot, of course, I can either make it or I can miss it. I'm not looking at these red boxes anymore because that already has an X associated with it with the first shot. So it's not like I can shoot another one. So in reality, I'm not even looking at these red boxes anymore, I'm just looking at the light greens. Here I have a dark green, and this dark green I'm going to use to represent making my second shot as well as making my first shot. So I know I have an 80% chance of this. If I have an 80% chance of making the second shot, and I have 80 total boxes, then I'm looking for 80% of 80. Now, I can count it up and I can do the math to find out what 80% of 80 is, but in reality, it's if I have 10 going this way and 8 going that way, 80% would just be 8 of these rows. So 8 of these rows, I'm going to have to try and do a little bit darker just so that you guys are able to see. And I think it's working just fine. But this dark green is going to represent something a little bit different. Beautiful. Dark green is representing making my first and making my second. Whereas the light green still represents just making my first shot. Making my first shot represents the check X situation, and I know it's kind of difficult to see. The red will just mean representing missing my first shot. And the dark green represents, I know it's hard to see, so don't worry, making my first, making my second. Right? Now, I'm going to represent this also using math. Right? So if we go back to the paper that we had that we were using to solve. Now, I can also solve mathematically. That's what I'm going to try and help you guys out with now. Similar to the grid, we are going to assume that we are taking 100 shots. So we can find a percentage. If I have 100 shots that I'm taking, and I make my first one, we know that every check is equal to 80%, and every X represents 20%. So if we're talking about making the first shot, we're talking about 80%. And 80%, I'm going to represent that as 0.8. Now making my second shot, again, I still have an 80% chance of making it, so that's 0.8 as well. And if I multiply these together, 100 times 0.8 is 80, times 0.8 would get me to 64. And that is the chances of me making my first and making my second. We can find that here, where we have 64 dark green boxes that represent making both. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5, 6, 7, 8. That's where I have my 64 makes. Now, I'm going to represent the second outcome, which is miss. So if I make my first shot, there's an 80% chance of that. But then in my second shot, I should say, there's a 20% chance that I miss. So now I have to do this. 100 times 0.8, which is 80, times 0.2, which is the same thing as finding 1/5 of 80. That will get me to 16. Now 16% is making the first, and again, missing the second. Making the first, missing the second. I can find that 16% with the light green. The light green, of course, was making the first, missing the second. The only other outcome that we haven't talked about yet, that we haven't solved for, is the red, which we know is 100 shots times the 20% chance that I will miss, because it is very unlikely. And there's nothing else here. There's nothing for the second shot, because again, I cannot take a second shot if I miss the first one. So it's just 20% of 100, which is equal to 20. That's just the miss. And of course, those 20 boxes are here. That is how you can represent this mathematically, by just multiplying those percentages that would happen. This is no different than if I said the chances of me getting heads is 1 in 2 times the chances of me rolling a 3 when I roll a die, that's a 1 in 6, and the chances of me spinning a spinner that has 4 equal sections labeled A, B, C, D, and getting a C, which is a 1 in 4 chance. If I multiply those all together, I would have a 1 in 2 times 6 is 12 times 4 is 48. A 1 in 48 chance of getting heads, 3, and C. 1 in 48 chance. So again, I'm doing math without having to do the tree diagram and et cetera, et cetera. We have different possibilities. You can use a tree diagram for this, don't get me wrong. However, you can also solve it mathematically without drawing the 100,000 branches that do not require that. We're talking about doing this as efficient as possible. So I think this is a very well-made strategy to solve without having to draw a grid or draw a tree diagram, et cetera, et cetera. I hope this helps.